Hey guys, yeah, today I wanted to talk about a the same system design problem I did last time, which was the URL shortener, and I kind of wanted to show like some new things I learned and how I can improve upon it. And so I already mentioned this, but I've been reading a little bit of this book. I would say I read this more as a guide, um, but if you want to actually get like the guide over building scalable systems, then you can actually go to Byte.go and get those articles for free. Like at this point, like the book is really more about practice problems. Another thing that I've been using was this. Why is my computer taking so long to load? But let me share my screen. Um, Another thing I've been using was this course over here. It's called Mastering the System Design Interview, and it's a really interesting course. It's like, yeah, I think as I mentioned, it's like 6 hours and 5 hours, but it goes through a lot of interesting content. And so I'm almost done with it. I'm actually at the part where I'm doing practice problems and kind of want to talk about some interesting things about doing URL shorteners and some things to kind of consider. So let's get started with this. Let's just kind of dig into the problem and get started. And I don't want to make the same mistake as I did last time, so I am going to open a Google Doc so I can write down the algorithms. Where's Google Doc? Oh, there it is. I was like, I swear I saw Google Doc. Okay, so let's get started with this. So first things first, let's actually use this Google Doc. I want to see if it's big enough for everyone to see. But the idea is to build a URL shortener. Okay. Wait, is there a better way to spell this? Shortener. Oh, yeah. Okay. So let's consider some ideas of building a URL shortener. Some interesting things is that, just to clarify what URL shortener is, it's like a similar website like Bitly, where you give it a long URL and it takes it in and it shoots out a shorter URL, which when you click, it'll redirect back to that original URL that you wanted. And so that's kind of the example that we're trying to build. And so some things to really consider about the URL shortener is like the scalability, like how much is this going to take in. And so as a good starting point, we can actually talk about hundreds of millions of URLs added to the website. 100 millions of websites. So that's one thing to consider. And then we can actually talk a little bit more on in situations whenever we need to consider like even more cases where this might have to go for billions, right? Um, Another thing to really consider about building a URL shortener is really about use cases. Um, so anytime you're like building in system design, at least for me as well, that I'm trying to get better at this, is that it's really easy to fall into the trap of looking at it really technically, but we kind of want to look at the user perspective as well. So if I was going to be using URL shortener, right? If you ever use Bitly, you'll notice that they have like a really nice type of URL that's kind of easy to remember. And so we kind of want to make it user friendly whenever we shorten that URL. And so that means we might want to eliminate special characters like an exclamation mark or at sign, a hashtag. You want to just leave it simple like lowercase letters and just numbers. And so the question is also like what is the shortest that we can do in order to fulfill this 100 millions of URLs that we were just talking about. I don't know why my mouse is being hidden. It's so weird that it's doing that. Yeah, but like, so that's one thing to consider is that we want to not use special characters, and we want to just simply keep it as A to Z, and we also want to keep it from 0 to 9. And so as we recall inside here, that leaves us with a total combination. So there's 26 letters in alphabets plus 10. That gives us 36 combinations, or sorry, 36 characters that we can leverage on. And so for in our case, we want to give it a really nice like use case for the users. We don't want to give them some long ass like characters that they have to remember. And So in that case, I think the best thing that we can actually shoot for is a total of, well, I guess we have to calculate this, but for example, if I were to build our website, right? So www.yourshortener.com. So I'm going to just use a total max of, like, I don't know, lowercase letters, or something like that, right? And it's pretty user friendly, right? Because we can remember that instead of having some really long URL that we have to paste, and defeats the purpose of making it friendly. And so in this case, I'm gonna shoot for 6. And so the way how we can calculate to see if it encapsulate the 100 millions of URLs is by learning a little bit of some permutations, right? And so our goal. So in the meantime, I'm going to see what happens if we just have a total of 6 characters versus having 7 characters. So let's calculate that right now. And so whenever you're using permutations, right, or this idea, you want to basically use this 36 as a base, and then use these 6 or the 7 as an exponent. And so like the number of combinations that you're shooting for, you use as an exponent for the base of 36. So 36 to the power of 6, 36 to the power of 6 is, what is that? That's 2 billion. That's 2 billion, which definitely encapsulates what we're shooting for, right? It definitely encapsulates the 100 million URLs that are being added to the website. So 6 characters is definitely a good way to go. And so if there was a case, whatever we were shooting for, like, well, actually, I'm just curious from my end, right? I'm kind of curious. If we take 36 to the power of 7, what would that result to? 378 billion. Yeah, so in that case, 6 characters actually, I think, would suffice. I don't think we need to go further than that. And I think what I was trying to shoot for was that I think we might not even want to use 7 characters, because if we were going to take the 7 characters route, so that means we will have to use lowercase a to z, and we will have to use uppercase a to z, and we will also have to account for, like, the numbers from 0 to 9. And so that would account as, I'm sorry, that's my dog. Amy. I don't know. That would result into a total of 62 characters. And so as we saw, I think that should actually be enough. I'm trying to think what happens if we made this like to 1 trillion 1 trillion URLs then. So 62 to the power of 6 would result to what? I'm just going to do this for the fun of it. Oops. Okay. Yeah, I think we'll be fine. I'm overcomplicating it, but yeah, in the meantime, we're just going to keep it as 6 characters then, if that's the case. And so that'll actually work for us, so we're going to be perfectly fine in that. Another thing to really consider is, like, do we want to give users the opportunity to, customize their own URLs? And so letting users customize their URLs. And so, yeah, definitely we want to do that. If we did it that way, though, we would also have to account for, passing a user ID, right, as part of the parameters, because that's the user authentication or some sort of opt-to token or something like that. And another thing that we would have to also consider with that is, people are going to want to edit, they want to delete, and they want to create a custom 6 characters URL as well. And so that's what they're going to be shooting for. So we're going to let users do that for sure. Okay, so we want them to have, we're counting for 100 million URLs. We want to avoid special characters, and we just decided that we want to stick with 6 characters that are just going to be a lowercase of a to z and number 0 to 9, which leaves us 36 characters that we can use. And we just calculated that this can handle 2 billion, so that's perfect. We also want the possibility that users can customize their URLs by passing user ID, edit, deleting, creating a custom 6-character URLs. Other things to really consider that I'm thinking about is like what happens in cases whenever we want to have these URLs being expired. And so for the sake of simplicity, we won't set an expiration date to these things. So no expirations to these URLs. But we can certainly delete them though. We can delete them. Right? We don't want some empty URLs inside our website. We just want to delete them if the user actually has access to creating those different URLs themselves, or those custom URLs. I feel like I'm missing some things. What other things should we actually consider as well? We got the users, we got the expiration dates. Yeah, I think we actually have enough in order to get this started. So let's just take these requirements and start working on this. So at the high overview, oh, this is going to bother me, that little bouncer thing. Let's do this. You can see I get irritated quite easily with small things. Okay, so yeah, let's work with these different types of requirements that we have over here. And so for me, we're going to start the client, right? So we have our client over here that is going to be interacting with our applications. And you know what? Let's get a little bit creative. We get computers inside here, right? Let's have 2 types of computers. Maybe we might have a mobile as well, a mobile phone added to that. Cool beans. A little bigger. Let's just kind of distribute these. So we have our client stuff that we are going to be using. And so at the end of the day, they're all going to be communicating with our load balancer. And so I would imagine that this is going to be a pretty, this is a system that we don't want to just be in the United States. This is a system that we want to happen throughout the world. And so we need to have a load balancer that can handle geolocation, essentially. So handle geolocation. Basically, it's going to look at our different server locations, and it's going to distribute based on those users' location on their client app side. And so yeah, let's just kind of draw this out. So we go here. I'm just going to do this because I like doing this, actually. I like this part. That's going to bother me. Oh, whatever. Oh my god. That does not look right. Okay, whatever. We'll just keep it like this. So I can handle geolocation. So we have all of our device that goes through this load balancer, and we are going to communicate with a REST API. And so I think before I even start, we kind of need to see how exactly our algorithm is going to work for this. So how are we going to we're going to go through an API, right? It just makes sense. And how is this going to be built? And so we're going to have a URL that's going to essentially handle shorten URL. I feel like I keep spelling wrong. And the parameters it's going to take is that long URL. And it's also going to be taking the I guess it's just going to take long URL, and it's just going to produce. And so this is going to be for users that are anonymous. I can spell anonymous. Is that how you spell anonymous? I don't want that. You spell it correctly. Okay. Oh, my mouse is annoying me. So this is going to be an anonymous endpoint, and so it's just going to produce some sort of short URL. And so another one we're going to have is another shortener. For the hell of it, let's just do this, right? If it was a anonymous user, then we can pass like some random GUID that we don't have to care about. But this is going to handle the user ID as well. So we can specify who that URL is for. So we have a long URL, and then we have like a user ID, and it's going to produce a short URL. So that's one endpoint that we're going to work with. And then we also talked about cases where we might have users that want to create their own custom URLs, right? So we might have a shortened URL that is going to take in a long URL, user ID, and we also are going to contain like the custom URL as well. And that will also produce a URL, short URL for us. And we also need to have cases whenever we want to verify whether or not that user has the URL. So we can actually, for example, sometimes users might just completely forget their short URL. So they want to pass in the long URL and see what URLs that they have already created. So we can do something like that, where we provide a long URL and user ID, and that will actually give us our short URL. So this is already created, but we're just wanting to map and see what we have. And of course, if there isn't any URL, then it just kind of throws an error of like not existing or not found. We also need to have a redirection. So, wait, what do I call this? Oh, I don't think I should call it shorten URL. I should say get shorten. I think our endpoint should actually do the work for that. Map to shorten URL. And this is going to be create custom shorten URL. I think I should capitalize these. So this is going to be a post request. Will be a get request. And oh wait, this is going to be a post request. Sorry. And this is going to be a get request. We already created it. We just want to see what our long URLs and the short URLs that we have already. And we need a redirection, right? So this is going to be another get request. And so this is going to be like redirect URL. And so the way that we're going to handle that is we just receive the short URL. That's it. And that's going to give us the long URL. And I guess also what I forgot to mention is that if we do create that custom URL, there's a few things we might need to consider, right? We want to be able to update it as well. So we might have a put request that is going to be like update custom shorten URL. So that's going to take in we're going to take in long URL and then the user ID. So that's how we're going to identify it, and we'll basically just return back the short URL for that. And then we also want to have delete, where we can delete the things that we created. So delete custom shorten URL. Just going to take a long URL and the user ID. And it's just going to return us some status of it. So I think these are like the main endpoints that we have. So we can create a short URL, we can create a custom short URL, we can actually update a custom URL that we already have, we can delete a custom shortened URL, we can map the shortened URL, a long URL to a short URL, and then we can redirect our URL, most importantly. And so the question is, like, for now, the algorithm, like, how are we going to be able to convert our long URL to those 6 types of characters? And so the way that we're going to do it, that is working in my line, is basically what we just kind of talked about over here. And so the idea is to essentially wait, hold up. Actually, that doesn't make quite sense if I do it that way. If I auto increment and I change it to base 64, so they have warned me that I should not be quiet. I should actually talk out loud in my mind. So what I am a little bit confused about is like, how do I actually convert it? And so like I could auto increment like a value, like it goes 1, 2, 3, 4, 5, right? And then eventually taking that number and converting it to base 36 base. But then the question is, then where do those letters come into the picture then? No, they will come to the pictures, right? Eventually. So if I have 6 characters, right, that is being created, and we have J, which represents that value, like so. So if I have like about a billion numbers inside there, interesting. I want to try something out. I really want to try something out. Huh. So we just calculated, right, that 36 to the power of 6. This is the maximum we can get, and we can auto increment to this maximum. But if I actually increase it a little bit more, I think it's going to throw an error. So if I say base 64, 36, base 10. Wait, base 10 to base 36. Right, so this is the value that I have. Okay, so it goes to the maximum to it. If I increase this 7, it just still works. Wait, what is this? Okay, something's not making sense to me. Wait, what am I trying to calculate? Now I'm starting to confuse myself. But yeah, I don't think that's what I'm actually aiming for. Oh yeah, I'm doing 36 to the power 36 to that. I see. So I think I get it now. I think what the problem is that when I say like 2 billion, I'm saying that if I do 6 characters, that's the max amount of IDs that I could auto increment. So max auto increment to 2 billion, which is actually not too bad. So what I was thinking of is one, have an auto incrementer. Increment numbers. So like from 1 to 2 to n, right? And so this is going to go over to 2 billion, essentially, eventually. And so we take that number and encode it to base 64. It's base. Oh, this is confusing. convert that to base. Base 36. I'm going to cheat a little bit. I want to see my book quick. Something's not making sense to me now. Okay. Take the num and encode to base. Wait, so if I take the number and I change it to base 36, then what's the benefit of doing it that way? I don't see any benefits of just putting that number as just an incrementer. I mean, I guess if we're just gonna auto increment, then and it's gonna be predictable, then what's the whole point of, right? Because if I get to 2 billion down here, eventually, I think without doubt I'll hit 2 billion, right? I guess it's a lot more user friendly, I suppose. It's a little bit more user friendly, I suppose. I guess it's mainly a security problem, but it's not a security problem because users can. I mean, I'm pretty sure they can understand the pattern of what's going on every time it's being incremented and what value it's going to be next. I need to ask that question because now I don't really understand the whole huge purpose of agreeing to base 36. Oh, I think I'm starting to get it now. Right, that was the limit. Now we increased to 6. Now we're going to 7 characters. So actually, we don't really have much of a limit that we're doing if we do it to base 64. Okay, I think I kind of get it. I guess it's just for security reasons. A lot of them are talking about encoding it, but I guess there's security issues of just showing the direct auto incrementing of values, right, to decrease it so it doesn't actually look as big. Yeah, that's one way to handle it. But yeah, I guess to answer that question, yeah, we take the num and we encode it to base 36, right? And once we hit that 2 billion, it will create a 7 character, which is not a problem for us. It's still going to be able to scale and be shorter than the actual auto increment number. Okay, and then all we are trying to do is so auto increment associate to a long URL. And so we change it to base 64. Okay, so that's actually pretty simple. And then we encode it to base 36. And then, yeah, I think that's kind of the algorithm that I'm shooting for. But this is kind of what our API is going to look like or consist of. on the side. So the great thing about this API is that we can make our servers or our REST APIs stateless, so we can actually horizontally scale it. And so I'm just going to call these servers inside here. So we have 4 servers in the meantime. And it's going to communicate with this guy. It's going to communicate with this guy. Oh my god. Is this fucking bullshit sometimes? You gotta be kidding me. And let's do this right here. Cool. And we'll decrease it. Okay, so we got the servers down, and then what we need in the center of all this is, so we're communicating with the server and it has to communicate with some database, but it'd be crazy because you're going to get a lot more read than actually write. And so we want to like use some sort of like Redis cache, like a centralized caching system to ensure that if the the server already exists, I mean if the URL already exists, then we just return it back immediately. And then we can actually use like if the cache becomes too full, which I expect for this type of system being so scalably high, then I would suspect it to we'll use the algorithm of the least recently used URL, short URL. So we'll just kick off the one that's least used. Okay, so we're going to use some Redis cache. Which is going to handle this stuff, and I'm just going to draw the picture again because I like drawing pictures. Oh my god. This is making me not like pictures now, though. Who's doing this? No. So it goes to Redis cache, right? And then that eventually goes to our database. And so the cool thing about doing an auto increment system is that we can now like use this to, we can horizontally scale our different types of databases. So we're going to be using a NoSQL for scalability reasons. So I'm going to be using a, I'm going to call these, can we actually have 2 masters databases? No, I don't think so. But I'm going to have this as the master database, right? That is going to take in all, yeah, so it's going to be taking in the right axis. And basically we're going to be able to distribute these. So these are its replica for it. Just gonna put this here. And this is gonna combine here. That just looks really weird why it's doing that. I guess we gotta do it this way. Right, so it communicates with a master database. And the great thing about doing it this way, by the way, is that we could we can put it as shards. And so this could actually potentially take the value of 1 to, I don't know, like 250,000. And this one takes like 250,000 to 500,000. So you kind of get the idea of what's going on, right? But is that we actually can break these databases down for easier accessibility, essentially. And so, yeah, that's the kind of the game plan that I'm imagining. Another reason also I just thought about this of why we're doing the base 36 type of thing. It's because instead of using like some sort of hash function, it's because it is always going to ensure uniqueness when we have those auto increments. There's only going to be a security issue whenever like it could be predictable to see like what type of next URL is going to be created. right? So we have all of this right here that's being created right now, and all these different types of URLs that's being created. 500,000. You actually might need this to go for a little bit more to the extent. Yeah. So really cool thing about this is that we also need to debate whether or not we want to do a 301 redirection or a 302 redirection. And so the idea is the client talks to the geolocation load balancer, which goes to the server depending on the client's location. And it's going to actually first look at the cache to see if that short URL exists. If it doesn't, it'll bypass it, go straight to the database, go back, save into the Redis, and provide the data. And because our database is sharded, it'll be able to get those databases even quicker. If our master branch, our master database falls, then we can actually replace it with a new. Oh, wait, we can't actually do that, can we? So I guess what I have to do in that case is I would have to make some sort of duplicate. So that is a single point of failure. And I can't just simply elect one of these guys in order to do it. So I kind of need to have something that reads directly into this master database or something like that. I guess I have to duplicate it by reading to another master database for that. And so cool thing about this is that if we actually force a 301 redirection, we can actually cast that cache it in the browser itself and put uh, less put less work on the server. And but if we decide to do a 302, we basically have to contact our server again in order to get that data back. So that would be good whenever we need to actually do some analytics with our problem. But for the most part, this is the system that we would build. Whew, that was rough. I was like thinking through this too hard. So I think it was good that I did this problem again because I might have to do this problem one more time, but I can see I have a lot of like whole cheese in my brain, so I'm not completely understanding the problem. So it was a good session. I'll work on it a little bit later, but thanks, Henry. Appreciate you being here. Talk to you later. Bye.